question 1. So we're given f of x, and the question says, given that x plus 3 is a factor of f of x, find the value of the constant a. So if x plus 3 is a factor, that means f of minus 3 must equal 0. That's the factor theorem. So we know f of minus 3 is 0, so we can substitute in to find a. So we've got 3 negative 3's cubed plus 2a times negative 3 squared minus 4 times negative 3 plus 5a. And we know that is equal to 0. So we can do these on a calculator if we need to simplify them on a calculator. I'm just going to write them down. So 3 times negative 3 cubed. Negative 3 cubed is negative 27. Times 3 will be negative 81. And we've got negative 3 squared, which is 9, times 2a. So that's 18a. We've got negative 4 times negative 3, which is 12. And we've got a 5a, and that's equal to 0. So we've got 23 a's in total. And we've got 81 minus 12, which is 69. So negative 69. 12 minus 81 is negative 69. So add the 69 to both sides and divide by 23. So a is 3. Question 2. So we've got figure 1, and it shows a plot of part of the curve with equation y equals cos x. So we've got the graph of cos x here. X is measured in radians, and on the opposite page is a copy of figure 1. So this is, if you've got the exam paper, you'll see the same graph in diagram 1. Use diagram 1 to show why the equation cos x minus 2x minus a half equals 0 has only one real root, giving a reason for your answer. So this, we can find the roots by rearranging this. We've already got cos x, and if we make this cos x equals, so if we get cos x by itself, plus 2x to both sides, and plus a half to both sides, the roots of this is going to be where the two graphs cross, where cos x crosses 2x plus a half. So we want to find where cos x is equal to 2x plus a half. So we can draw the graph of y equals 2x plus a half on the grid. So we want to draw the graph of y equals 2x plus 1/2. So remember that this is 1 and this is negative 1. And the graph of 2x plus a half has got a y-intercept at a half. So it's going to cross at 1/2. And so we've got pi, half a pi here. So this is 3, 2, 1. So it's got a gradient of 2. For every 1 it goes across, it's going to go up 2. So it's going to be up here. For every 1 it goes back, it's going to go down 2. 1, 2. It's going to come down here. So if we get a ruler and connect these up, we can see that the graph of y equals 2x plus a half crosses our graph of y equals cos x 1 time. So that's why it's got 1 real root. So giving a reason for your answer. So the graph of y equals cos x intersects y equals 2x plus a half once. Part B, so we've got given the root of the equation is alpha, and alpha is small. We can use the small angle approximation for cos x to estimate the value of alpha to 3 decimal places. So the small angle approximation of cos x says cos theta or cos x is approximately equal to 1 minus theta squared over 2. So that's our small angle approximation that we're going to be using. So instead of cos x, we can write 1 minus x squared over 2. So 1 minus x squared over 2, and then we've got minus 2x minus a half equals 0. I'm going to multiply everything by 2 to start with to get rid of these fractions. So I'm going to have 2 minus x squared minus 4x minus 1 equals 0. So the fractions are gone. We've got a quadratic. I'm going to bring everything over to the right side, so x is positive. So I've got x squared plus 4x. And then we've got 2 minus 1, so we've got 1 on the left side. So we have minus 1 on the right side. And then we have to solve this. So let's use our calculator. Menu, equation or function. A polynomial, degree 2, it's a quadratic. So we've got 1x squared plus 4x minus 1. So what are the solutions? We've got 0.236 and we've got minus 4.236. So I suppose we could write them both down. Let's write them both down. So it's 0.236 or we've got minus negative 4.236. So which one's the solution? Well, it's the first one. It's not negative 4, it's 0 point something. So not this one. Reject from the graph. It's this one. Question 3. So here we're given y equals 5x squared plus 10x all over x plus 1 squared. And we need to show that dy dx is equal to something over x plus 1 to the power of something. So we're going to differentiate, and it's a fraction. It's in the form y equals u over v. So we're going to be using the quotient rule. So the quotient rule tells us, so when it's y equals u over v, dy dx is equal to v du dx minus u dv dx all over v squared. So u is the top of the fraction, 5x squared plus 10x. So du dx is that differentiated with respect to x. So times by the power, take 1 off the power. 10x plus 10. V is the denominator, the bottom of the fraction. So v is x plus 1 squared. So we're going to differentiate that as well. So times, it's a chain rule, times the whole thing by the power. So 2, keep the bracket as it is. So to the power of 1. And then times by the bracket differentiated. And that's just going to be 1. So that's it differentiated. 2 times x plus 1. So now we can write dy dx is v times du dx. So I'll put a bracket 10x plus 10. So du dx times v minus u times dv dx. So I'll write dv dx first. And then again, I'll use a bracket for u. And that's all over v squared. So x plus 1 squared squared. So x plus 1 squared times x plus 1 squared. That's x plus 1 to the power of 4. So now we just need to simplify this until it's in this form. And we can divide every term, or both terms on the top, and the denominator by x plus 1. So it's a bit like factorizing x plus 1 out of the top, and then cancelling off an x plus 1. So I'm going to divide both terms on top by x plus 1. So this squared will go away. And I'll cancel off this x plus 1. And that cancels off with 1x plus 1 at the bottom. So now it's only cubed on the bottom. And now I will expand the brackets on the top. So 10x plus 10 times x plus 1. So that's 10x squared plus 10x plus 10x plus 10. And we've got a negative 2 times both of these terms. So negative 2 times 5x squared, negative 10x squared, and negative 2 times 10x, negative 20x. And that's all over x plus 1 cubed. So now we're just simplifying the top line. So we've got 10x squared minus 10x squared, which is nothing. We've got 10x plus 10x minus 20x, which is nothing. So that just leaves us with 10 over x plus 1 cubed. And that's in the form we wanted it. So we can see that a is 10 and n is 3. Part B says, hence deduce the range of values for x for which dy dx is less than 0. So we've got our dy dx here. When will it be less than 0? So when will it be negative? And it'll be negative, well, when the denominator is negative. A positive divided by a negative will be negative. So dy dx is less than 0 when the denominator is less than 0. And what makes the denominator less than 0? It will have to be, x will have to be less than negative 1. So x is less than negative 1. That will make the bracket negative, and when you cube a negative number, you get a negative answer. So x has got to be less than negative 1 for this to be negative. Question 4. Find the first 3 terms in ascending powers of x of the binomial expansion of 1 over the square root of 4 minus x, giving each coefficient in its simplest form. So we're expanding 1 over the root of 4 minus x. So 1 over the root of 4 minus x is the same as 4 minus x to the power of minus a half. So a square root is a power of a half, and to flip the fraction, it's a negative. So 4 minus x to the power of minus a half. And we want our binomial expansion. To do the binomial expansion, we want it in the form 1 plus or minus something. So what we'll do is we'll take 4 outside of the bracket. So we'll take 4 outside, and it'll still be to the power of minus a half. We'll have 1 minus a quarter x inside. So we're factorizing out 4. So 4 times a quarter is 1 to the power of minus a half. So we can do the expansion of this bracket, and we'll just leave 4 to the power of minus a half on the outside. And 4 to the power of minus a half is the same as a half. Square root, that'd be 2, and then flip. So it's half times this expanded. And the expansion is 1 plus n times x. So minus a half times minus a quarter x. 1 plus nx plus n times n minus 1. So it's minus a half times minus 3 over 2 over 2 factorial, so 2 times x squared. The first 3 terms, 1, 2, 3. So let's simplify this now. I'm going to use the calculator just because that will be easier for us. So we're going to have a half, and 1 is the first term. Then for the second term, we have minus a half times minus a quarter. And that's 1/8. So a negative times a negative is a positive, and it's x, 1/8 x. Then for the next term, our x squared term, we have minus a half times minus 3 over 2 over 2 times minus a quarter squared, and that'll be our x squared term. So 3 over 128 x squared. So to finish this, we're going to multiply through by the half. So half times 1 is a half. A half times an eighth is a 16th. And a half times 3 over 128, that'd be 3 over 256. So there are our first 3 terms. And the expansion can be used to find an approximation for root 2. Possible values of x that could be substituted in are negative 14, because that would find this, -2 and -half. Without evaluating the expansion, state which of these values should not be used. So our expansion is valid when our x, so 1/4 x, is less than 1. So that's when it's valid. So when x, or the mod of x, is less than 1. And if you will multiply both sides by 4, so valid when x is less than 4. So the expansion is only valid when our x term, so this bit here, is less than 1. So only when x is less than 4 is this valid. So we can't use -14. So the mod x is less than 4. So the mod of x is less than 4. So we can't use it because 14 is more than 4. So we can't use 14. So part B, point I, -14 as the expansion is valid when mod x is less than 4. And the second part, which of these values would lead to the most accurate? Will it be the lowest one? So the smallest one, so -1/2. So -1/2 will be more accurate than 2 because it's smaller. So -1/2 because it is smaller, or the mod of it is smaller, closer to 0. Question 5. So we've got f of x is equal to 2x squared plus 4x plus 9. And we need to write this function in the form incomplete. We need to complete the square. A open bracket x plus b squared plus c. So we're completing the square on this function for part A. So let's go straight into that. So f of x equals 2x squared plus 4x plus 9. We need to take 2 outside of the bracket. So we'll take 2 outside, and we'll have 2 times x squared makes 2x squared. 2 times 2x makes 4x. And I'll close the bracket there and just leave the plus 9 on the end. So I'm going to complete the square on this bracket. So just on the bracket part. So 2, I'm going to open a big bracket, and then I'm going to complete the square. So half the b term, so we've got x plus 1 squared, take away this number squared, so take away 1, and close the big bracket, and we've still got the plus 9 on the end. So I'm going to expand this bracket now, so get rid of the big bracket with a 2 on the outside. So 2 times x plus 1 squared is 2x plus 1 squared. 2 times -1 is -2. And I've got a plus 9 on the end. So I'm just going to add -2 plus 9, which is 7. So there we've completed the square. We're in the format that was asked for. Part B, sketch the curve, showing any points of intersection with the axis and the coordinates of any turning point. So we've got a positive x squared graph. So it's a U-shaped graph, U-shaped curve, and we can use this format to find the minimum point. So the minimum point, so the minimum x value, the minimum point is where this bracket is equal to 0. So x has got to be -1. And then if the bracket's worth 0, we've got 0 squared times 2, which is 0, plus 7. So y will be 7. So the minimum point's at -1, 7. So that's up here. And it's a U-shaped curve, so it's not going to cross the x-axis. It's got no intercept for x, but it has got a y-intercept. So it crosses y when x equals 0. And when x is 0, 2 zeros plus 4 zeros plus 9 is 9. So y is 9. So let's draw this curve. Minimum point at -1, 7, crosses y at 9. So -1, 7, crosses y at 9, and it's a U-shaped curve. So something like that. So that's part B done. Part C, describe fully the transformation that maps the curve with equation y equals f of x, so our original one, onto the curve of equation y equals g of x, which is this. So what has changed from this to this? So let's have a look. So f of x minus 2 would be a good place to start. So f of x minus 2 is 2 times x minus 2 squared. 2 times x minus 2 squared plus 4 times x minus 2 plus a 9. So we wanted the 2 times x minus 2 squared bit. We wanted 4x minus 3 after that. So we've got the 2 times x minus 2 squared. If we expand this bracket, we've got 4x, which is what we wanted, minus 8 plus 9. So it's not quite the one we wanted, because we've got a plus 1 on the end. And we wanted, so we've got all of this, we wanted a minus 3 on the end. So what we'll do is we'll take 4 off. So it'll be f of x minus 2 minus 4. And that is our curve, that's g of x. So g of x is f of x minus 2 minus 4. So what's the transformation? So it's a translation by the vector. So inside the bracket changes the x, and if it's -2, it goes the other way, so it goes 2 to the right. So 2 in the x direction, and outside the bracket changes the y, and it says -4, so it goes down 4. So it's a translation, 2 right and 4 down. So we've got another part II, find the range of the function, and that's called h of x, and it's 21 over our original function. So find the range of the function, 21 over our original function. So let's use the completed the square. So 2 times x plus 1 squared plus 7. So h of x is equal to 21 over 2 times x plus 1 squared plus 7. So that was our original function in our completed the square form. And we want to know the range. So what can the outputs be of this? If we use the smallest thing the denominator can be, that was the minimum point. So that was when x was -1. If x is -1, we're left with 7 on the bottom, and 21 over 7 is 3. So it can equal 3, and that's if the denominator's at its smallest point, it will be 3. As the denominator gets bigger and bigger, this, well, it can reach infinity. It's got no limit. So 21 divided by 1,000,000 is a very, very, very small number. It's never going to reach 0. So it's going to get closer and closer to 0, but never reach it. So we can say h of x will be bigger than 0. So anything all the way up to 0, and it will be less than or equal to 3. So it can equal 3 when the denominator is at its smallest point, and as the denominator gets bigger and bigger, it gets closer to 0, but never reaches it. Question 6. So we've got solve theta, and we want the answers between -180 and +180. The equation 5 sine 2 theta equals 9 tan theta. If necessary, answer to 1 decimal place. So we need to solve this. So we need to use, well, sine 2a, sine 2 theta. So sine 2 theta is 2 sine theta cos theta. And we'll also use tan theta is sine theta over cos theta. So let's change these. So that should help us. So that'd be 5 times this. 5 times 2 is 10. So we've got 10 sine theta cos theta is equal to 9 sine theta over cos theta. So we can multiply by cos theta, multiply both sides by cos theta. So 10 sine theta cos squared theta equals 9 sine theta. Now we don't want to divide through by sine theta, we'll lose answers that way. We want to make it equal to 0 and then factorize. So 10 sine theta cos squared theta minus 9 sine theta is equal to 0. And we're going to factorize out our sine theta. So we take sine theta outside the brackets. That leaves us with 10 cos squared theta minus 9 inside the brackets, and that's equal to 0. So either sine theta equals 0, or 10 cos squared theta minus 9 is equal to 0. So let's solve this for cos theta. So we'll plus 9 to both sides, and then divide by 10. So cos squared theta is 9 tenths. So plus 9 to both sides and divide by 10. And then to get cos theta by itself, square root. And so we'll have the positive or negative square root of 9 tenths. So we've got lots of different answers here. We need to know all the ones between -180 and positive 180. So where's the sine graph equal to 0? Does it include these? Yes, it does. So sine starts at 0, and then it will be every 180 degrees. So theta can be negative 180, 0, and 180 degrees. So there are 3 answers there. Then we've got all of the answers that are going to come off this as well. So we'll start with the positive square root of 9 tenths. So are we in degrees? Can't see. So angle, make sure we're in degrees. So we'll start with the positive square root of 9 tenths. So shift cos square root of 9 tenths. So 18.4. So cos theta equals root 9 tenths, or cos theta equals negative root of 9 tenths. So theta is 18.4. So our cos graph, to get our next answer, we will take away from 360, so 341.6. We want between 180 and negative 180 and positive 180, so we don't want that answer. The cos graph repeats every 360 degrees, so we want the answer negative 18.4. For our negative one, so shift cos the negative square root of 9 tenths, so 161.6. And again, we'll do 360 minus answer, which is 198.4. We don't want that. But it repeats every 360, so we'll go back 360, negative 161.6. So we've got all of those answers. Deduce the smallest positive solution to the equation. So what have they done here? They've changed our theta has been changed to x minus 25. So the smallest positive solution, changing x to x minus 25. So the smallest one, if we add 25 to it, will be negative 18.4. So add 25 to negative 18.4, and we get 6.6. So 6.6 degrees. Question 7. In a simple model, the value V pounds of a car depends on its age T in years. The following information is available for the car. Its value when new is £20,000. Its value after 1 year is £16,000. And we need to use an exponential model to form a possible equation linking V and T. I think the easiest way to do this will be to use our geometric sequences. So UN equals a times r to the power of n minus 1. So a is the first number, and a is 20,000. R is the common ratio. So the common ratio is 16,000 over 20,000, 16 over 20. So R is 16 over 20, which is 8/10 or 4/5. So V equals 20,000 times 4/5 to the power of n minus 1, but we want this in terms of t. So the second term is going to be after 1 year, the third term is after 2 years, so it's just t. So there is an exponential equation linking v and t. If we did it the other way, we would have used a, e, k, t. So a would have been the 20,000, and we would have had to use t as 1 when v is 16,000 to find k, and then we would have had a different kind of exponential equation. Part B, the value of car A is monitored over a 10-year period. Its value after 10 years is £2,000. Evaluate the reliability of your model. So let's use our model after 10 years. So 20,000 times 4/5 to the power of 10. 20,000 times 4/5 to the power of 10 is £2,147. So let's comment on the reliability of this model. So the car's worth £2,000. That's close to 2,147. So it seems reliable. So our answer, the model's estimate of the value, is close to the actual value. And we've got a different car, car B, for part C. It's got the same value when new. So A is still 20,000. Its value depreciates more slowly, so it goes down slower. Explain how you would adapt the equation so that it could be used for car B. So how would we adapt this? Well, the 4/5 would have to be bigger, so closer to 1. So the common ratio would be closer to 1. So if it was 9/10, it would go down slower. The value would go down slower because the common ratio, the smaller the common ratio, the faster it's going down. So the common ratio will be closer to 1, be greater than 4/5. So greater than 4/5. And closer to 1. So between 4/5 and 1. And that would make it depreciate slower. Question 8. So here we've got a sketch of part of the curve of equation y equals x times x plus 2 times x minus 4. And what I'm going to do first, because we've got this equation in the factorized form, I know, or I can find the roots of the equation. So it's 0, which is shown in the diagram, negative 2, and positive 4. We've got the region R1, so we know that's between 0 and negative 2, bounded by the curve and the negative x-axis. Show that the exact area of R1 is 20 over 3. To find the area under a curve, we use integration. So we're going to be integrating this, and it's between 0 and negative 2. So we've got the integral between 0 and negative 2 of our function x times x plus 2 times x minus 4 with respect to x. I'm going to have to expand this before I can integrate. So we're going to expand these brackets. I'm going to leave the x first and expand the double brackets. So x times x is x squared. X times negative 4, negative 4x. 2x's are 2x. And 2 negative 4's are negative 8. I'm going to simplify the terms inside the bracket. So I've got x squared minus 4 plus 2 is minus 2. So x squared minus 2x minus 8. And then I need to multiply through by x. And then I'll be ready to integrate it. So I'm going to multiply through by x, which gives us x cubed minus 2x squared minus 8x. X cubed minus 2x squared minus 8x. So now we're ready to integrate. To integrate, we add 1 to the power and then divide by the new power. So x cubed, add 1 to the power, so it'll be a 4. And then divide by the new power, which is the same, dividing by 4 is the same as multiplying by a quarter. Minus 2x squared, add 1 to the power, so 3, and then divide by the new power. So minus 2/3 x cubed, minus 8x, add 1 to the power, so it will be 2. It's 1 at the moment, it goes up to 2, and then divide by the new power, 8 over 2 is 4. And then we would have a plus c on the end, but we don't need to include it, because we're going to be, well, we'll take it away from itself, so it will disappear, even if you did include it. So now we're going to substitute in 0 and substitute in negative 2 and take the negative 2 away from the 0. If I substitute 0 in here, well, it's going to be 0, take away 0, take away 0. That's 0. So let's do the negative 2 one. We've got a quarter of negative 2 to the power of 4 minus 2/3 of negative 2 cubed minus 4 times negative 2 squared. And I'll type this into I'll type the whole thing into the calculator, and it should give me our answer. So we want 0 take away 1/4 of negative 2 to the power of 4 minus 2/3 times negative 2 cubed minus 4 times negative 2 squared. And we've got 20 over 3, which is what we wanted. Okay, the region R2, again shown on the diagram, is bounded by the curve, the positive x-axis, and the line of equation x equals b. So this line here, where b is a positive constant between 0 and 4. Given the area of R1 is equal to the area of R2. So these two areas are equal. Verify that B satisfies the equation. So we know the area between B and 0 is the same. And because it's below the curve, instead of 20 over 3, we should get an answer of negative 20 over 3. So what I'll do is I'll say that a quarter, so the integrated version, this one here, part B, a quarter times x to the power of 4 minus 2/3 of x cubed minus 4x squared between b and 0 must equal negative 20 over 3. So the area under the curve between b and 0 is negative 20 over 3. This is positive 20 over 3, and below the curve we'll get a negative answer. So above the curve will be positive, below the curve will give us a negative answer. And, well, if we substitute in b, we're just going to get 1/4 b to the power of 4 minus 2/3 of b cubed minus 4b squared, and then take away 0. So take away 0, which we can just leave, equals negative 20 over 3. And now it's just a case of getting this to look like this. So it's a rearrange what we've got now to make it into this form, to get it into this form. So it's factorizing it really. And so we're going to get it all on one side and then try and take out some factors. Try and factorize it, put it into brackets. So let's get it all on one side first. So add 20 over 3 to both sides. 1/4 b to the power of 4 minus 2/3 b cubed minus 4b squared plus 20 over 3 equals 0. I want to get rid of these fractions. So I've got 1/4 and 1/3. So to get rid of them all in one go, I can multiply by 12. I can either multiply through by 4 and then multiply through by 3 in 2 different steps, or I could just multiply by 12 in one go and it will get rid of the 4s, the quarters and the 1/3. So I'm going to multiply every term by 12. So 12 times 1/4, 12 over 4 is 3. So 3b to the power of 4. 12 times 2/3 will be 24/3, which is 8. 12 4s are 48. And 12 20s are 240. Over 3 is 80. So now I just need to factorize. We could use the factor theorem to try and find a factor. We know b plus 2 is a factor. So we know b plus 2 is a factor. So let's go straight to taking b plus 2 out of this. So we could check b plus 2 is a factor using the factor theorem and say if we substitute in negative 2, it would equal 0. So if we substituted in negative 2, it would equal 0. So we could say x plus 2 is a factor. So if we check this, that will tell us that we've got the right equation that we're working with. So 3 times negative 2 to the power of 4 minus 8 times negative 2 cubed minus 48 times negative 2 squared plus 80. And that's 0. So we know that this is correct. We're working with the right thing. And now it's just a case of factorizing it. So x plus 2 is a factor. So we can do algebraic long division, or we could use the grid method. I think I'm going to use the grid method. So x plus 2 multiplied by something. So I have an x cubed, an x squared, an x and a number equals 3b to the power of 4. I said b plus 2, sorry. We want b plus 2, not x. So b plus 2 is a factor. B plus 2, and we want b 3b to the power of 4. So b times something makes 3b to the power of 4. That would be 3b cubed. And then 3b cubed times 2 is 6b cubed. We want negative 8b cubed. So we need to take away 14b cubed. B times what makes negative 14b cubed? That's negative 14b squared. 2 times negative 14b squared is negative 28b squared. We want negative 48b squared. So we need to take off another 20b squareds. B times negative 20b squared. No, what multiplies by negative 20b squared? What do you have to multiply b by to get negative 20b squared is negative 20b. 2 times negative 20b is negative 40b. We want no b's. We've got no b term. So we need to add on 40b's. B times 40 makes 40b. And 2 40s are 80. So we have b plus 2 times 3b cubed minus 14b squared minus 20b plus 40. And we need to factorize it again. We need to take another b plus 2 out of this. So we need to take b plus 2 out again. So take b plus 2 out of our answer to our last part. So again, we're going to have b plus 2 and we're going to take it out. We want 3b cubed. So b multiplied by what makes 3b cubed? 3b squared. 3b squared times 2 is 6b squared. We want negative 14b squared. So we need to take off 20b squareds. B times negative 20b gets negative 20b squared. 2 negative 20b's are negative 40b. We want negative 20b, so we want to add on 20b. B times 20 is 20b, and 2 20s make the 40. So now we've factorized it, and we have b plus 2 times b plus 2 times 3b squared minus 20b plus 20. So that's b plus 2 squared times 3b squared minus 20b plus 20. And that's what we wanted. Equals 0. So I'll go back and add that on to everything. Equals 0. And there we have it. It is factorized. There's a part C. So the roots of the equation 3b squared minus 20b plus 20 are 1.225 and 5.442. So 1.225 and one up here of 5.442. The value of b is therefore 1.225. Explain with the aid of a diagram the significance of the root 5.442. So why have we got this root 5.442? So the area between 5.442 and 0 must be negative 20 over 3. So how can that be? How can this whole area be the same as this little r2? It's because the area on top is going to be positive, the area underneath is going to be negative, so they'll cancel each other out. So the area between 0 and 4, take away the area between 4 and 5.442 is equal to 20 over 3. So it says explain with the aid of a diagram. So part C, explain with the aid of a diagram. So let's draw a diagram. So what did it look like? It looked something like it went down and then up. So we had B there. So that's 1.225 and 5.442. So this, we call that the green area. We'll have the purple area. You can just label them. You can 1, 2, and 3. I'll do that. So 1, 2, and 3. So explain with the aid of the diagram the significance. So it's area 1 is equal to area 1 plus area 2 minus area 3. So in words, the area between zero and 4 minus the area between 4 and 5.442 is equal to the area between 0 and 1.225. Question 9. Given that A is bigger than B and B is bigger than 0, and that A and B satisfy the equation log A minus log B equals log A minus B, show that a equals b squared over b minus 1. So we know from the rules of logs that if we've got log a minus b, log a minus log b even, that's the same as log a divided by b. So a minus is the same as a divide, and a plus is the same as a times. So two logs added together. So log a plus log b is log ab, and log a minus log b is log a over b. So log a over b is equal to log a minus b. And because both sides have got a log on and they're equal, that means a over b must be equal to a minus b. So we can just get rid of the logs and just say a over b is equal to a minus b. Then we're just rearranging, so multiply both sides, multiply by b. So a equals b times a minus b. Then we can, well, expand the bracket. So b times a is ab, b times b is b squared. We want the b squared, we want it to be positive, so let's bring the b squared over, so plus b squared to both sides. And then take away a from both sides. Then we can factorize out the a. So a times b makes ab. A times -1 makes negative a. Now we're almost there. Divide both sides by b minus 1. So a is equal to b squared over b minus 1. And that's what we wanted. Write down the full restriction on the value of b, explaining the reason for the restriction. So we know that we've got to explain the reason. So b can't equal 1 because if you divide by 0, the denominator will be 0. You can't get an answer. It's undefined. And we also have this restriction given to us in the question. So we know that a and b are both positive. So a and b are both positive, and a is also bigger than b. So for b to be positive, it's got to be above 0. So b's got to be greater than 0. But for a to be positive, b minus 1 has got to be positive. So b minus 1, so a positive, b squared is always positive. A positive divided by a negative will be negative. So b minus 1 has got to be positive, which means b has got to be bigger than 1. So that's the restriction. B's got to be bigger than 1. And then any answer, as it gets bigger, a will be bigger than b. So that's not a problem. So if we have 2, we'll have 4 over 1. Yep, that's not a problem. So we've got b has got to be bigger than 1. So let's write that as our answer. B's got to be bigger than 1. And then b cannot equal 1 because a would be undefined, would be dividing by 0. And b's got to be bigger than 1, otherwise if b is anything less than 1, otherwise a would be negative. Question 10. Prove that for all numbers n squared plus 2 is not divisible by 4. So n squared plus 2 is not divisible by 4. What we can do here is we can say, we can split this into odds and evens. So if n is even, we can say n is 2 m's. So it's in the 2 times table, 2 times something. So if n is even, n is 2 m's. So we'll have 2 m's squared plus 2. 2m squared, 2m times 2m is 4m squared. So we've got a 4 times table plus 2. And a 4 times table plus 2 is not in the 4 times table. So this is 2 more than something in the 4 times table. Therefore, not divisible by 4. And if it's odd, if n is odd, we can say n is 2m, the 2 times table, plus 1. So we've got 2m plus 1 squared plus 2 this time. And we'll square this, so 2m plus 1 times 2m plus 1 plus 2. So that's 4m squared plus 2m plus 2m plus 1 plus 2. So 4m squared plus 4m plus 3. So it's the 4 times table, something in the 4 times table, a multiple of 4 plus 3. So 3 more than the 4 times table, 3 more than something in the 4 times table, so we could say it'd be odd, therefore odd, and not divisible by 4. And so if it's odd or even, it's not divisible by 4, so it's not divisible by 4. Okay, so part II. Given that x is a real number from the set of real numbers, the value of the modulus of 3x minus 28 is greater than or equal to the value of x minus 9. State, given a reason, if the above statement is always true, sometimes true, or never true. So the easiest way to do this is probably to sketch their graphs. So we'll have the graph of y equals 3x minus 28, the mod of 3x minus 28, and the graph of y equals x minus 9. So if we sketch both these graphs, on the same axes, we'll be able to see when one's greater than the other. So we've got a modulus graph that's always positive. It's 3x minus 28. So it would have intersected at minus 28. It's got a gradient of 3. So what we really want is a dotted line. So I did freehand dotted line up here. So it would have gone up there. So this part of the graph we have, and then the other part that we would have had down here reflects back up in the positive side, and it intersects at positive 28. So what's this value here? It crosses x when y equals 0. So 0 equals 3x minus 28. So 3x equals 28. X is 28 over 3. So this intersection here is at 28 over 3. How about the graph of x minus 9? Well, it's got a y-intercept at minus 9, negative 9, and a gradient of 1. So it's going to cross at positive 9 here, and 27 over 3 is positive 9, so slightly to the left of this other graph. So 27 over 3, 28 over 3, just make a note of that. 28 over 3 is 9 1/3. So we've got 9 1/3 here, and 9 right next to it. So the question said, is greater than or equal to, so it's always greater or equal to. Is that true? So is our red graph always above our blue graph? Well, no, it's not, no. So we can see that between well, somewhere in here, our blue graph is going to be above. So definitely at 9 1/3 at 28 over 3, our blue graph will be above our red graph. So it's sometimes true. It's not always true. A lot of the time the red graph is above, but sometimes the blue graph's above. So it is sometimes true. Sometimes true. State given a reason. So at x equals 9, at x equals 9, it is greater, but at x equals 9 1/3, the other graph's bigger. So at 9, the red graph's higher. At 9 1/3, the blue graph's higher. Question 11. A competitor is running a 20-kilometer race. She runs each of the first 4 kilometers at a steady pace of 6 minutes per kilometer. After the first 4 kilometers, she begins to slow down. In order to estimate her finishing time, the time that she will take to complete each subsequent kilometre is modelled to be 5% greater than the time she took to complete the previous kilometre. Using the model, so part A, show that her time to run the first 6 kilometres is estimated to be 36 minutes and 55 seconds. So we've got 4 kilometres that took 6 minutes each. The first 4 take 6 minutes each. So that's 24 minutes. So for the 5th kilometre, so we've got 6 times 1.05. So it's 5% greater. To add on 5%, we can multiply by 1.05. So 6 times 1.05 is 6.3. That's 6.3 minutes. I don't like that. So I'm going to press this time button here. 6 minutes and 18 seconds. I'm going to store that. Should I store that? Right. So 6 minutes. 6 minutes, 18 seconds. And then we need to multiply by 1.05 again. This is a geometric sequence. So to find the term, un equals a times r to the power of n minus 1. So we want 6 times 1.05 squared. So if 6 was the first number, I know this is the 5th kilometre, so that's a bit confusing. So if the 4th kilometre was the first one, then the 5th one is the 2nd term, the 6th kilometre will be the 3rd term. So 6 times 1.05 squared. So adding on 5% twice, so we've got 6.615, and that's 6 minutes and 37 seconds to the nearest second. I'll store that as B. So 6 minutes, and I've forgotten what that was, 37 seconds. So if we add them all up, 24 plus our 2 previous answers. So I've saved them as A and B. So we've got 36.915. So in time, 36 minutes and 55 to the nearest one, 36 minutes, 55 seconds. And that was what we wanted. So 36 minutes and 55 seconds. So part B, show that her estimated time in minutes to run the rth kilometre for r between 5 and 20 is 6 times 1.05 to the power of r minus 4. So r minus 4. So the 5th one, so the 5th kilometre was 6 times 1.05 to the power of 1. The 6th kilometre is 6.1.05 squared. The 7th kilometre is 6 times 1.05 cubed. So it's always 4 less. So 6 times 1.05 to the power of r minus 4. So 5 minus 1 is 4, 6 minus 2 is 4, 7 minus 3 is 4. So it's 6 times 1.05 to the power of r minus 4. Estimate the total time that it takes to complete the race. So there are 20 kilometers. So we need to do a sum. So the sum of a geometric sequence is a times 1 minus r to the power of n over 1 minus r. This is made slightly more complicated because the first 4 kilometers all had the same speed, so they weren't part of a geometric sequence. We can say the first, well, we can either start with the 5th one or start with the 4th one. So let's say the 4th one is the first one in our sum. So the first 3 kilometers, so we do the first 3 kilometers, which will be 6 times 3, 18 minutes. So we'll split that off, and then we'll have the next 17 kilometers that we will work out. So using our formula, we'll work out the next 17 kilometers. So S of 17 is A, which is 6, times 1 minus R, which is 1.05 to the power of n, 17, over 1 minus R, 1 minus 1.05. So this will tell us the 17 kilometers, and then we'll add on the first 3, and that'll be the total. 6 times 1 minus 1.05 to the power of 17 over 1 minus 1.05. 155. So I just write down the 155, and then again we want in minutes and seconds. So let's change that to minutes and seconds. So 155 minutes and, well, 3 seconds, because it's over 30. So 155 minutes and 3 seconds. And we need to add on 18 minutes. 18 minutes plus 155 minutes plus 3 seconds. So 18 and 155 make 173. So 173 minutes and 3 seconds. Question 12. So we're told that f of x is equal to 10 times e to the power of minus 0.25x times sine x, where x is greater than or equal to 0. And we need to show that the x coordinates of the turning points, so the turning points are where dy dx is equal to 0. So we need to differentiate it and make it equal to 0. And we should get, so if the curve satisfy the equation, 10x equals 4. So we're going to differentiate it, make it equal to 0, and then we should be able to simplify it for the answers to give us 10x equals 4. So let's give this a go. We're differentiating. We've got two things times together here. So it's the product rule. It's in the form u times v. So one's u, we can say u is 10e to the power of minus 0.25x, and we can say v is sine x. So they're multiplied together. So we'll have du dx is this differentiated. And when we differentiate e, it, well, stays as it is. So it's just a chain rule. We need to multiply by the bracket, so the power differentiated. And that's minus 0.25. So minus a quarter times 10 is minus 10 over 4, or minus 5 over 2. E to the power of minus 0.25x. That's du dx, dv dx. So we're differentiating sine x. So we can remember this, sine x on top, cos x on the bottom. We differentiate, we go clockwise. Sine goes to cos, and cos goes to minus sine. So sine x differentiated is cos x. And so now we need to multiply these two together. V and du dx. Multiply these two together, and we add them up. So put a plus in the middle. So dy dx, or f dash of x, I think that was the notation we were using, is these two multiplied together. So I'll put the e one first, so minus 5 over 2 e to the power of minus 0.25 x times sine x plus these two times together, 10e to the power of minus 0.25 x times cos x. So there we've differentiated it, and the turning points are where this equals 0. So where minus 5 over 2 e to the power of minus 0.25 x sine x plus 10e to the power of minus 0.25 cos x is equal to 0. So how can we solve this? Well, we can factorize out the e's. So let's factorize out our e to the power of minus 0.25x. So let's take e to the power of minus 0.25x outside the bracket. And then inside, we're left with minus 5 over 2 sine x plus minus 5 over 2 sine x plus 10 cos x equals 0. Now our e function, e to the power of minus 0.25x, cannot be 0. So this, you can think of this as one bracket. That's going to have no solutions. It can't be 0. So this bracket must be 0. So we can say that minus 5 over 2 sine x plus 10 cos x must be equal to 0. And to solve this, we're going to plus 5 over 2 sine x to both sides. So 10 cos x equals 5 over 2 sine x. Then we can divide both sides by 5 over 2. Or, well, we could multiply both sides by 2 and then divide by 5. Or think of it as 10 over 2.5. So 10 divided by 2.5 is 4. So 4 cos x equals sine x. And we wanted a tan, and we can get tan with sine over cos. So divide both sides by cos x, and we get 4 equals tan x, and that's what we wanted. Tan x equals 4. Okay, so now we're looking at the graph. So figure 3 shows a sketch of part of the curve with equation f of x. So that's the curve we started with. Sketch the graph of h against t, where h of t equals, well, the modulus of this function. So x has been changed to t, but it's just the same function, but the modulus, so it's always positive. Everything below the x-axis is going to be reflected above it. So it's going to be all of the curves will be above the x-axis. So they're higher every time, and they'll get smaller and smaller. So let's draw this h against t. So we've been given a space to draw it. So we've got h, t, and so we're just going to have these curves, these waves, getting smaller every time. So the first one should be the highest, and then the next one shallower, and then shallower again, something like that. So getting shallower every time. And the function h of t is used to model the height in meters of a ball above the ground t seconds after it's kicked. So let's look at this and say what's going on. So the ball's kicked in the air, and then it goes back down to the ground, and then it bounces up, and then back down, bounces up and down, and so on. So that's what we're dealing with. Using this model, find the maximum height of the ball above the ground between the first and second bounce. So the turning points were where tan x equals 4. So we've got tan t equals 4. So this will tell us the t values of the turning points, and then we'll have to substitute them in to find the h values. So tan t equals 4, so t is shift tan 4. And it doesn't say specifically whether we're in degrees or radians. I think we can assume we're in radians, because if we were in degrees, so if we've got, if t's in degrees, it's going to be going, 180 degrees, 180 seconds, and it's unrealistic that a ball will be bouncing for that long. So I think we should, it'd be bouncing for minutes and minutes. So we can assume we're in radians. It doesn't say though. So we'll do this in radians. So in radians, shift tan 4, arc tan of 4. So we want to make sure our calculator's in radians. So angle unit radians. And we're doing shift tan 4, which is 1.33. And then the next answer, so add on a pi. The tan graph repeats every pi, or every 180 degrees. 4.47. And so we wanted the maximum height of the ball between the first and second bounce. So that's where it kicked in the air. That's the first bounce. That's the second bounce. So we want the second answer. So there's our 4.47. So t is 4.47. So I'm going to store that as a 4.47. That's our t value. We need to substitute it in to find h. So h is the mod of 10e to the power of minus 0.5 t sine t. So h is was it 10e, 10e to the power of minus 0.5 t sine t, and it was the mod of it, sine t. Okay, so we just need to substitute in here our 4.47. So let's use the calculator. We can do a mod, can't we? Shift bracket, no, shift bracket, yep. So 10e to the power of minus 0.25 a. We stored our answer as a. Sine a. And we've got 3.18. We'll go with that, 3.18. So h is 3.18, and that's in meters. In meters, yeah. Explain why this model should not be used to predict the time of each bounce. So, well, the time of each bounce is, we're adding on pi every time. So each bounce is just over 3 seconds after the previous bounce. So it's unrealistic because the bounces should get closer together. So we can say the bounces should get closer over time, not stay the same. Or the time between the bounces, the time between the bounces. The time between the bounces should get closer over time, not stay the same. Question 13. The curve C with equation y equals p minus 3x over 2x minus q times x plus 3, where p and q are constants, passes through the point 3, 1/2, and has two vertical asymptotes with equations x equals 2 and x equals -3. Explain why you can deduce that q equals 4. So these asymptotes are going to be where we can't divide by 0, or dividing by 0 is undefined. So x is -3, that makes this bracket 0, and x will have to be 4 no, x will have, if x is 2, q has to be 4. So if q is 4, it makes x 2. So 2x minus 4 is 0 when x equals 2. So 2x minus 4 is 0 when x equals 2. And show that p equals 15. So we know it goes through the point 3.5. So we've got, so for I, y equals p minus 3x over 2x minus 4 times x plus 3. And then we know it goes through 3.5, 3 1/2. So x is 3 when y is a half. Two 3's minus 4, so I'm just substituting in. X is 3 and y is 1/2. And that will find p. So what have we got here? We've got 1/2 equals p minus 9 divided by 2 3's are 6 minus 4 is 2. 3 plus 3 is 6. So half equals p minus 9 over 12. Half equals p minus 9 over 12. Multiply both sides by 12. So 12 halves are 6. Add 9 to both sides. P is 15. And that's what we wanted. So figure 4 shows a sketch of part of the curve C. The region R shaded, so is bounded by the curve, the x-axis, and the line with equation x equals 3. Show that the exact value of the area of R is this. So something ln 2 plus b ln 3. So we need to know where it crosses the x-axis. So it crosses x when y is 0. And we're going to have to integrate to find the area under the curve. So we have, this is part B. So I'm just going to write down the equation again. So y is equal to, and it was 15 minus 3x over 2x minus 4 times x plus 3. So it crosses the x-axis when y equals 0. So that gives us 0 equals 15 minus 3x over 2x minus 4 times x plus 3. It's going to be 0. Well, if we multiply both sides by this, we get 0 equals 15 minus 3x. So x is 5. So it crosses x when y is 0. So x is 5. So this is 5. So we're integrating. And we want the area between 5 and 3. So to integrate this, we need to split it into partial fractions. So we're going to say that 15 minus 3x over 2x minus 4 times x plus 3 is equal to a over 2x minus 4 plus b over x plus 3. So let's think of this as multiplying through everything by 2x minus 4 times x plus 3. So we've got 15 minus 3x left on the left side. And we've got a, the 2x minus 4's will cancel. So we've got a times x plus 3. And we've got b, the x plus 3's will cancel, times 2x minus 4. So if we eliminate a by substituting in when x is -3. So 15 minus 3 negative 3's. So 15 plus 9 is 24. A's eliminated, 0 A's is 0, equals B times, so 2 negative 3's are -6, minus 4, -10. So -10B equals 24. So B is negative, dividing both sides by -10. Positive divided by negative is negative. 24 over 10 is 2.4. So B is -2.4. When X is 2, we eliminate B. So we've got 15 minus 3 2's. 15 minus 6 is 9. And we've got 2 plus 3 A's, 5 A's. So 9 is 5 A's. Divide both sides by 5. A is 9/5. I'm going to write 1.8 just because I don't want one as a decimal, one as a fraction. It doesn't matter. So there we go. We've got partial fractions now. Now we can integrate. So we want the integral between 5 and 3, I think. Yep. Of a 1.8 over 2x minus 4. And it's minus b, so I put the minus here. 2.4 over x plus 3 with respect to x. So now we're going to integrate. So these are going to be, so it's in the form 1 over x, so it's going to be a ln. Each one will be a ln. So 1.8 ln 2x minus 4, and we need to divide by the bracket differentiated, which is 2, so over 2, and then we've got minus 2.4 ln x plus 3, and then I'm not going to plus c because we're going to take them away, so between 5 and 3. So let's substitute in the 5 and the 3. So I'm going to change this 1.8 to 0.9 as well. So 0.9 ln, so substituting in 5, 2 5s are 10, minus 4 is 6, minus 2.4, 5 plus 3 is 8, and then we're going to have a minus 0.9 ln 2 3s are 6, minus 4 is 2, minus 2.4 ln 3 and 3 makes 6. So then we need to go over the page. So 0.9 ln 6 minus 2.4 ln 8. .48 minus 0.9 ln 2 and it's a minus minus, so it's plus 2.4 ln 6. Okay, so we've got, or we can add our ln 6's together. So 0.9 and 2.4 is 3.3 minus 2.4 ln 8 minus 0.9 and then 2. Now what do we want? We want a ln 2 plus b ln 3. So how can we change these? So we can change ln 6, it's a log, so to 3 plus 2. So 3.3 ln 2 plus ln 3. So ln 2 plus ln 3 is the same as ln 6. 2 3s are 6. And ln 8 we can change to 2 cubed. So minus 2.4 ln 2 cubed. And this is log e 2 cubed, so the 3 can jump down to the front. And that'd be 3 2.4s. So we've got 3.3 ln 2 plus 3.3 ln 3 minus 7.2 ln 2 minus 0.9 ln 2. So they're all 2s and 3s. So let's just add them up. So our 2s are 3.3 minus 7.2 minus 0.9, which is minus 4.8. So we've got 3.3 ln 3s minus 4.8 ln 2s. And I think that's the form we wanted. A ln 2 plus b ln 3. Well, we can just write it the other way around. And there's our answer. Question 14. The curve C in the standard Cartesian plane is defined by the equation x equals 4 sine 2y, where y is between negative pi over 4 and pi over 4. The curve C passes through the origin. Find the value of dy dx at the origin. So it's in the form x equals at the moment. So we can find dx dy. So let's get dx dy. So x is 4 sine 2y. dx dy is, so sine differentiates to cos. So we've got cos 2y, then times by the bracket differentiated, which is 2. So it's going to be 8 cos 2y. That's dx dy. If we want dy dx, we're just going to flip it. So it's going to be 1 over 8 cos 2y. And we want the value of dy dx at the origin. So when y equals 0, when y is 0, dy dx is 1 over 8 times cos 0. And, well, 1 over 8 cos 0 is 1/8. Cos 0 is 1. So that's 1/8. That's part A. Part B. Use the small angle approximation for sine 2y to find an equation linking x and y for points close to the origin. So an equation linking x and y for the points close to the origin. So sine, the small angle approximation for sine theta is theta. So sine theta is approximately equal to theta. So sine 2y will be approximately equal to 2y. So x equals 4, and then sine 2y will be approximately equal to 2y. So it'll be 4 times 2y, which will be x equals 8y. Is that what we wanted? Equation linking x and y for points close to the origin. So x equals 8y. Explain the relationship between the answers to part A and part BI. So what's the relationship between these two answers? So the gradient at 0 is 1/8. And if we rearrange this, so x equals 8y, if we divide both sides by 8, we'll get y equals 1/8 x. So the gradient of this line is equal to the gradient at the origin. So the gradient of both is 1/8. So the gradient of the line linking x and y for small numbers is equal to the gradient at the origin. So the gradient for points close to the origin is 1/8. And part C, show that for all points x and y lying on C, dy dx equals 1 over a times root b minus x squared, where a and b are constants to be found. So we're taking dy dx and we're getting rid of the cos, well, we're getting rid of the y, sorry, getting rid of y and changing it into in terms of x. So we're getting dy dx in terms of x. So let's do that. So dy dx equals 1 over 8 cos 2y. Dy dx equals 1 over 8 cos 2y. And we want to get rid of y, and we want x. So what links x and y? X equals 4 sine 2y. So how can we change this into this? Well, we can change cos into sine using cos squared. So cos squared 2y plus sine squared 2y is equal to 1. Cos squared x plus sine squared x equals 1. So to get cos 2y by itself, so cos squared 2y will be 1 minus sine squared 2y, and then we square root to get cos 2y by itself. So cos 2y is the root of 1 minus sine squared 2y. So we have, so going back to our dy dx, we can change cos 2y into this. So dy dx is 1 over 8 times the root of 1 minus sine squared 2y. So we haven't got rid of the y's yet. We can change it into x's though, because sine 2y. So this is a bit confused. I'm going to write this again. So x equals 4 sine 2y. So sine 2y is x over 4. So sine squared 2y. So square both sides. So x over 4 times x over 4 is x squared over 16. So I can substitute x squared over 16 in for sine squared 2y. So 1 over 8 times the square root of 1 minus x squared over 16. So we've got it in terms of x now. That's what we wanted, but we need to get it in a certain form. So 1 over a times root b minus x squared. So we need x squared by itself, well, not with the fraction it's with. So if we change the 1 to 16/16, so add these fractions, at the moment it's 1 over 1, so, or 1 is the same as 16/16, so we'll have 8 times the root of 16/16 minus x squared over 16. Then we can add the fractions, so it'll be 8 times 16 minus x squared over 16. And then we can split off this root, so this is all over the root. We can split it into two roots. So we can have 1 over 8 times root 16 minus x squared over root 16. And root 16 is 4. So 1 over 8 times root 16 minus x squared over 4. And, well, we can say it's a quarter of root 16 minus x squared. Or we can think of this as the 8 being on the top as well. 8 over 4 is 2, or a quarter of 8 is 2. So it's 1 over 2 times the square root of 16 minus x squared. And now it's in the form that we wanted.